Welcome DIKWP, Shogun aboard. Your learning journey starts now. Alright, let's dive straight into the deep end. We're talking about the DIKWP times. DIKWP semantic interaction space. Sounds complex, right? But what if I told you it's a framework that could explain why some AI systems are brilliant, others are just okay, and none of them can truly think outside the box? That's the puzzle we're cracking today. So, what's this DIKWP thing? It's basically the classic DIKW pyramid: data, information, knowledge, wisdom, but with a crucial twist: purpose. This P layer isn't just tacked on, it connects back to everything else, creating a network, not a ladder. Now, imagine two such systems interacting. That's our DIKWP times DIKWP model. Think of it as a 5x5 grid of possible connections. Any layer in System A can talk to any layer in System B. We formalize this using tensor mappings, m of x to y. So, data from System A can become information in System B, or purpose from A can dictate what data B collects. It's a rich, multi-dimensional playground for semantics. Now, here's where it gets interesting. This whole DIKWP cross DIKWP setup is mathematically proven to be closed and self-consistent. What does that mean? Closed means whatever semantic magic happens within these 5 layers stays within those 5 layers. You can't suddenly invent a 6th type of meaning. Self-consistent means it won't crash itself by having contradictory thoughts. Higher levels like wisdom or purpose will smooth things out. But here's the catch. This neatness comes at a cost. Innovation is boxed in. You can only mix and match existing concepts, use the predefined 25 pathways, and the system actively tries to keep things stable, potentially killing off radical ideas. Your AI's creativity is limited by its training data and the rules you baked in. No magic wands allowed. Okay, so if it's closed, how does innovation even happen? It's not about adding new stuff, it's about doing old stuff in new ways. We define innovation as a leap, a sudden jump in the semantic state. Think quantum tunneling for ideas. How? 2 main ways. First, superposition, smashing together concepts that normally don't hang out, like mixing math and biology. Second, compression, taking a messy pile of different information and squishing it into a shiny new, simpler idea. Mathematically, we can think of this as a regular transformation T, getting a little kick from an anomaly delta T. That delta T represents those weird, non-standard connections firing up, leading to something genuinely new within the system's boundaries. But even with these leaps, there are limits. This closed system has its breaking points. For example, wisdom and purpose can get stuck in a tug-of-war, creating an unsolvable conflict. Imagine an AI knowing a task is impossible, but being forced to do it, its internal compass spins wildly. Certain profound concepts, like love or true beauty, might be fundamentally uncreatable if the system lacks the raw data or structure for them. There are also practical limits. You can't easily jump too many layers at once, like going straight from raw data to wisdom and trying to completely flip a core belief. The system might just shut down. Plus, that D to I to K to W path to wisdom can sometimes spit out surprises you didn't see coming, showing the system's complexity can lead to emergent weirdness. So, wrapping this up, the DIKWP cross DIKWP model gives us a powerful lens to view how cognition and innovation work, especially their limits. It's a closed loop, which is great for stability but puts a ceiling on radical breakthroughs. Innovation still happens through clever internal shuffling and those tensor leaps. The big takeaway is understanding these boundaries helps us strategize how to squeeze maximum value out of the system we have, maybe through smarter resource management or letting it evolve within its own rules. Want to break free? That's where thinking beyond DIKWP, maybe adding meta layers or nonlinear intentions, becomes crucial. Food for thought.